Welcome back, students. Last class, in the last video, I explained you the concept of orthographic projection, and you have understood what is orthographic projection, what is first angle projection, what is third angle projection, what are the differences between them, and what is the symbol used to represent the method of projection. This was what was told to you in the last class. Now today I am going to take up drawing number 2, which is projection of points. So as soon as we enter projection of points, the object is going to be just a point to you. It is just a point in space. Now you have seen what is the front view, the top view and side view of an object in the last video. But if I have to explain what is the definition of a front view, let us say there is a point here in space. If I want to get its front view, I project it onto the vertical plane. If I want to get its top view, either I project it onto horizontal plane or I project it onto ground or onto the roof. We call it as the top view. Similarly, if I want to get the side view, I project the point onto either the right wall or the left wall, depending on what view you want. So if I have to give you the definition of these views, the front view is defined as, the front view of a point is defined as the projection of a point on VP. The projection of a point on VP is called its front view. Similarly, the projection of a point on HP is called its top view. Similarly, projection of a point on profile plane, right profile plane or left profile plane is called the profile view. So let me write down the definitions here. Projection. When I say projection, it is understood it is orthographic projection. Projection of a point on VP. VP means vertical plane, the front wall. On VP is called its front view. FV stands for the front view. Similarly, projection of a point on HP. It could be ground or it could be the roof in a room. Projection of point on HP is called its top view. And then projection of a point on PP. PP means profile plane, the side wall of the room. PP is called the profile view or side view. You can call it side view or profile view. Okay. So this is the basic definitions of orthographic views. I once again repeat. Projection of a point on VP is called its front view. Projection of a point on HP is called its top view. And projection of a point on PP is called its profile view. Okay. Now, whether it is an actual point in space or its front view or top view or the side view, it is a point only. So when you represent a point on your drawing sheet or on your sketchbook, how to differentiate between what is an actual point, what is the top view and side view. This is how you are going to show or differentiate between them. Capital letters A, B, C, D, they represent actual points in space. So if I put a point on my drawing sheet and write it as capital A, yes, you understand that it is the actual point in space. But if you take the lower cases, small a, small b, small c, small d, they represent the top view of points. The other name given for the top view is plan of a point. Similarly, A small letter with a dash, A dash, B dash, C dash, D dash, etc. They are called front views of the points. Then what is side view? How do you represent a side view? A small letter with a double dash, A dash, A double dash, B double dash, C double dash, D double dash. They represent profile view. You can also call it side view. So this is how you will be able to differentiate between the points once you locate a point on your drawing sheet or on your sketchbook. Okay. Okay. Now, whatever I had shown you earlier was in a 3D scenario. In a room, the environment is 3D. But when you draw on a drawing sheet, it is a 2D scenario. So we are converting a 3D scenario into 2D scenario. 2D means just a plane of paper or a plane of board. Now let us see how to convert this 3D scenario into 2D scenario in projection of points. This is very important. Now for the time being, let us restrict ourselves only to VP and HP. Let us consider the profile planes later. In first angle projection, your VP and HP are like this. If this is your HP, this is your VP in first angle projection. This is just like a ground, this is your front wall. So a VP and HP in first angle projection, they are represented like this. Okay. So what did I do to bring the horizontal plane into the plane of the vertical plane? I rotated the horizontal plane by 90 degrees so that they are brought into same plane. So this has become a 2D scenario now. This was 3D, two mutually perpendicular planes you have. You converted it into 2D scenario by rotating the horizontal plane by 90 degrees so that they are in the same plane. Now there is a line which is common to both VP and HP. That line is what is called as a reference line. Okay. So what is a reference line here? If you take a room, this is your VP and this is your HP, horizontal plane ground. There is a line of intersection between VP and HP that can be considered as reference line. So what is reference line? It is an intersection of VP and HP. It is an intersection of the vertical plane and horizontal plane. Normally it is represented as a line. You have to draw it as a thin line when you use your software. So you should use a 0.13 mm thickness, and it is represented by XY. You should write capitals X and Y at the end of the line. This is a representation of the reference line. If you are following first angle projection, just now I have shown you, this is your VP and this is your HP. This is VP, HP is here. You have imagined it to be rotated in clockwise direction and brought it to the same plane of VP. So HP has gone down. This is the representation of a reference line for first angle projection. Then how do you represent it for third angle projection? Your roof is VP. Your roof is HP. When you imagine the roof is rotated by 90 degrees, it's like this. It's like this. This is the roof, which was HP. Imagine that the roof is rotated by 90 degrees and brought into the same plane of VP. So HP is on the top now. Okay. And when you write the reference line, xy once again, but you write HP here and VP here. This is for third angle projection. Why Sir is talking only about first angle, third angle, and what about second angle and fourth angle? You might get a question from your side. I'll explain you. But you don't have second angle and third angle projection methods. I'll explain you why they are not followed clearly when we further proceed. Okay? But for the time being, accept that you have only two methods of projection in orthographic projection. One is the first angle and the other is third angle projection. And this is how the reference line is represented for them. This is for the first angle projection, this is for the third angle projection. Once we enter projection of straight lines, the next topic or the next chapter, we will be restricted only to first angle projection because we are following only first angle projection in India or as per your syllabus. Okay. But as long as we are in projection of points, we will be discussing the position of a point in all the four quadrants. What are they? Let me explain to you. Then I will move on to the problems. Okay, let me come to the quadrants part later, but let me explain you the position of a point with reference to the vertical plane first. I'll come to the quadrants part later. Position of a point with reference to vertical plane VP. Let us say this is a vertical plane, wall, just like a wall. How many positions a point can occupy with reference to the wall? The point can be in front of the wall, the point can be behind the wall, or it can be on the wall. So three positions a point can occupy. What are they? In front of VP, behind VP, on VP or in VP. Okay. So what are the three terms? Behind VP, behind the wall, in front of VP, in front of the wall, and on VP or in VP. So just now what I have shown you is a 3D scenario. I have put a wall here, this is the front wall, in front of VP, behind VP and on VP. So how do you show this on a sheet of paper? How do you represent this? Okay. Just now I have shown you what is a reference line. The reference line represents both VP and HP. It is just a line. Now let me draw that line and show to you. In projection of points, we don't write VP and HP because we are discussing the position of a point in all the quadrants. That means we are following first angle, third angle, everything here. So I don't write anything here. Now, when you have a point behind VP, how do you represent it on with reference to XY line is the question. Okay. Now this is your VP. Let us say there is a point behind the wall. Okay. Now I want to obtain the top view of the point. If you want to obtain the top view of the point, what do? You project it onto HP, onto the ground. Now if this is VP, when you project this plane onto the horizontal plane, you get a line. That's nothing but the reference line. So you just have a line. Imagine that line is here. this VP, which is a plane, when you project it, what do you get on the ground? You get a line. Let us say I have drawn that line here. Now you have a point behind VP. That point also you have projected, let us say. You get a point on the ground, that is called its top view. So with reference to the XY line, where the point has gone above XY line. The top view has gone above XY line. So if I have something like this, let me call it as A, small a. Small a represents the top view of the point. What I got now is the top view of the point only. This is your VP. The point is behind VP. There is a point, that is the actual point in space. I wanted to get its top view. So what did I do? I projected it onto HP. I get a point. So with reference to the line that you have on the ground, the point has gone above. That is what I have represented. With reference to XY, I have represented the top view of a point above XY line. But what is its actual position in space? It is in fact behind VP. So in a 3D scenario, I had the point A behind VP. So in a 2D scenario, how are you representing it? You are representing it by a top view, and the top view is shown above XY line. Similarly, if the point is in front of VP, the actual point is in front of VP now. Now this VP is represented by a line on the ground, XY line. What is the position of the front view when you project it? It comes below XY line. Is it not? The front view comes below XY line. So if I put a point here and write B, B is nothing but the top view of the point B. Its actual point in 3D scenario should have been in front of VP. So point B is in front of VP. Similarly, if I put the point on VP and project it, it exactly comes on XY line. Okay? So C, if I have a point C on XY line, I can write point C is on VP. So is that clear to you now? All the 3 points are the top view of the points, because in all the 3 points I have projected onto HP. The projection on HP is called its top view. This is top view of A, this is top view of B, this is top view of C. But the top view of A is shown above XY line. That means it is behind VP. Here the top view of B is shown below XY line. That means it is in front of VP. If the top view of C is shown on XY line, you can say the point C is in VP or on VP. So whenever you are showing the distance of a point from VP, it is shown by representing the top view. Keep it in mind. Okay. Once again I repeat, if the top view of a point is shown above XY line, we say the point is behind VP. If the top view of a point is shown below XY line, we say the point is in front of VP. If it is on XY line, it is on VP. So this is the position of a point with reference to VP. How do you convert the 3D scenario into 2D? This is how you convert. In a 3D scenario, you had actual points, but in 2D, you have their projections. You have the top views here. That is the difference. Now, let us take HP and see how a point can occupy the positions with reference to HP. Let me erase this. Now let us see what is the position of a point with reference to HP. Let us take the plane once again. This is the plane. This is HP now. Earlier VP was like this. Now this is HP. What positions a point can occupy with reference to HP? Once again, 3 positions. The point can be above HP, it can be on HP, or it can be below HP. 3 positions. This is a 3D scenario. Now, what is your reference line? Imagine this plane is projected onto vertical plane. You get a line here. When this is projected like this, you get a line on horizontal plane, on vertical plane. So that line is your XY line. This is your XY line. Now let us say if there is a point above HP. So when you project it onto here, where do you get? You get it's above XY line. Similarly, if the point is below HP and when you project it on front wall, you get it below HP. The front view is obtained below XY line. If it is on HP, the front view is obtained on XY line. It's quite simple to understand. Okay, once again, this is the HP, horizontal plane. Let us say there is an actual point D above HP. When you project it, it becomes D dash, and that comes above XY line. Let us say there is another point E which is below HP, capital E. This is the actual point in space. When projected, you get the front view, it becomes E dash. It is below XY line. Similarly, if there is a point F on HP, it becomes F dash when projected, and that comes on XY line. So, with reference to HP, a point can occupy 3 positions. Above HP, below HP, and on HP. These are the 3 positions a point can occupy with reference to HP. And this time, you are representing front views. In the previous case, the distance from VP, you are represented it by representing the top views. But now, you are projecting onto vertical plane. So they become front views. Let us say D dash. What is D dash? It is the front view of point D. So if this is the point, I say point D is above HP. Similarly, if I put some point here and write E dash, it is the front view of the point E, and you find it below XY. So I say point E below HP. What I am writing in brackets is in a 3D scenario. Okay. Similarly, if you put a point here and write F dash, I can write point F is on HP. Okay. So this is how you represent the distances of a point from HP. The options are above HP, below HP, and on HP. So in the previous case, when I represented the distances from VP, I used XY as VP. But here I am using XY as HP. It represents both. XY represents both VP and HP in a 2D scenario. So I think it is clear now for you what a point can occupy, what positions a point can occupy with reference to VP and with reference to HP. Now, let us simultaneously see the position of a point with reference to both VP and HP. Let us position it. Let us position the point with reference to both VP and HP, and let us see how to draw the projections. Please follow carefully. This is very important in projection of points. Once you understand this concept, then the projection of points is done. I will draw one big XY line, X, Y. When when you draw XY line, I told you XY line should be a thin line, 0.13 mm thickness. X and Y should be capitals. X should be written at the starting of the line and Y at the end of the line. You can't write X and Y here. If you write X and Y here, that's wrong. Okay? X should be written at starting of the line and Y at the end of the line. There. Now, let me represent the top and front views of a point A with reference to VP and HP both. Now let me represent the distances as well. Say this is 20, this is 30. In the first drawing, you have learned how to draw a dimension line. This line, what is drawn here, is called as projector. The projector has to be drawn perpendicular to XY line always. The angle should be 90. And it also has to be a thin line. The projector has to be a thin line. When I say thin line, you should use 0.13 millimeters thickness when you use your software. So a projector has to be perpendicular to XY line and it should be a thin line. And also, what is this? This is the top view of point A. If top view of point A is here, its front view also should lie on the same projector. That's very important. This is the front view of the point A. It can occupy any position on this projector, but it should be on the same line. What I mean to say is, if A is here, I can't draw A dash here. This is wrong. The top and front views of a point should be on the same projector. Can you tell why? Why they should lie on the same projector? Let me explain it here. Let us say the planes are here like this, HP and VP. Let's say there is a point A here. Okay? This A, you are projecting here, you get the front view. The same A, when you project on here, you get the front view. Top view. Okay? This is the actual point in space. This is its front view and this is its top view. Now imagine this is rotated by 90 degrees. This was A here and this is A dash. You will find that both should lie on the same line after rotation. They lie on the same line. This is the reason. Once again I can show you, it's like this. There is a point A here in space. You got its front view here, then top view here. Okay? So let us say this is A and this is A dash. When I rotate, A dash will exactly go below A. That's the reason why when you are representing a point is A here. Both A and A dash should lie on the same projector. That's very important. Let us say this is the case that you have point A. Now from this, I want you to tell me what is its position in space with reference to VP and HP. So I am doing the reverse now. From 2D, I am going to 3D. From 2D scenario, you should be able to imagine what is the position of the point in space. Yes, let us take the top view first. Whenever you find a top view on your drawing sheet, the distance should have been from VP. If you recollect, in the first case, whatever distances I have shown, by representing a top view, that distance is from VP. So whatever distance I have shown here should have been the distance from VP. When I say from VP, if this is VP, when I say from VP, it can be in front of VP or it can be behind VP. Which case is this? You find the top view above XY line. So this should be behind VP. So I can say the point A is 20 mm behind VP. Now let us take the front view. This is the distance. So this distance should have been from HP because this is front view. When you see front view, the distance is from HP. When I say from HP, again you have two options with reference to HP. It can be above or it can be below HP. Which case is this? You find it below XY line. So you can say the point A is below HP. So what do you conclude? What is the position of a point A in space? The point A is behind VP and it is below HP. Accepted? I repeat once again. Because I find the top view above XY line, it should be behind VP. And because I find the front view below XY line, it should be below HP. So my statement is like this. The point A is 20 mm behind VP and 30 mm below HP. I am talking about the actual point A in space. So don't say point A dash and all. You don't have point A dash. There is only a point A, capital A. Okay, so what is your statement or what is the position of the point in space? Point A is 20 mm behind VP and 30 mm below HP. So that is the position of the point in space. You are able to imagine and tell with this as a reference. Now let me give you another point. Let us take another point B. Let us take the distance once again as 30 mm. Let us take the top view. When you draw this, when you are actually drawing the projections, only the point should be shown dark. You will be using 2 mm thickness when you use your software for the point, and this is thin, 0.13. This line is a thin line, the dimension line is also a thin line. This is how you write the dimension for a vertical line, 30. Okay, now this is the top view. The top view is kept on XY line. So what is its position with reference to VP? It is on VP. When I say top view, you should talk in terms of VP. When you find front view, you should talk in terms of HP. So I can say the point B is there on VP. And this one, it is below HP. 30 mm below HP. So what should be my statement? The point B, capital B, is on VP or in VP and 30 mm below HP. Let us take another point. Let us say C. I can change the point like anything, like whatever I want, but I must draw them on the same projector. Both the top and front views should be represented on the same projector. Let us say this distance is 10 mm and this is 30. So where do you find the top view now? The top view is below XY line. So what should be its position with reference to VP? It should be in front of VP. The point C is in front of VP. And you find the front view below XY. So it should have been below HP. So my statement is like this. The point C is 10 mm in front of VP and 30 mm below HP. I repeat again, the point C is 10 mm in front of VP and 30 mm below HP. Now I will take another point D. Let us say both are coinciding. 30 mm. How do you read this? Just pause your video and read it. Point D, the top view is here, so it is in front of VP. Point D is 30 mm in front of VP and 30 mm below HP. The distance is same here. Now let us take another position, point E. Pause the video and read out the position for yourself. This is the top view. You find the top view below XY. So it should be in front of VP. And here you find the front view above XY. So it should be above HP. So my statement is point E, capital E is 10 mm in front of VP and 20 mm above HP. Next. Pause the video and read. State its position in 3D scenario. Point F is on VP and 30 mm above HP. I repeat again. Point F is on VP and 30 mm above HP. Next. Let us say this distance is 10, this is 30. The top view is above XY line, so it should be behind VP. The front view is also above XY line, it should be above HP. So the point G is 10 mm behind VP and 30 mm above HP. They can also coincide like this, H and H dash, 30 mm. Pause the video and read the position of the point. Point H is 30 mm behind VP and 30 mm above HP. And finally, point I. What is this? Point I is on HP and on VP. When you have a point on the intersection line, intersection of VP and HP, it lies on XY line. So we say it is on VP and on HP. So if you understand this, if you are able to read the position of a point, it's done. It's almost done. Projection of points. Okay. Now let me come to the quadrants part. Okay. And also I will explain you why you don't follow the second angle and fourth angle projection methods. What is the reason? And what are these quadrants? Let me explain you. With that, we will finish this video. You can imagine the space to be divided into 4 quadrants like this. just like your trigonometry, the space is imagined to be divided into 4 quadrants by means of 2 planes. Imagine there is a vertical plane here, VP, there is a horizontal plane here, HP. Okay? So I have divided the plane into 4 quadrants with the help of 2 mutually perpendicular planes, VP and HP. Now if there is a point in first quadrant here, can you tell me what is its position with reference to VP and HP? Imagine the observer to be in the first quadrant always. The observer position is here. So when you have a point in first quadrant, for the position of the observer, I can say the point is in front of VP. Similarly, with reference to HP, I can say the point is above HP. I'll write down the same thing in first quadrant. If there is a point in first quadrant, I can say it is above HP and in front of VP. Is that understood? Now if you have a point in second quadrant, what is its position? Observer is there only. Observer position is fixed. The point is behind VP and it is above HP. I'll write it here. Above HP and behind VP. For the third quadrant, can you pause the video and imagine? It is below HP and behind VP because the observer is there only. This is the position of the observer. It is below HP and behind VP. What if it is in fourth quadrant? It is in front of VP and below HP. Below the horizontal plane and in front of vertical plane. Is this understood? You have divided the space into 4 quadrants using 2 mutually perpendicular planes, a VP here and a HP here, and you are able to imagine their positions when the observer is there in first quadrant. The observer position is fixed there. Now, yes, this is a 3D scenario. Let me go back to 2D. As soon as I say 2D, it is XY line. Now, if I give you the projections of a point, you should be able to tell me in which quadrant the point lies, making use of this. Let me take a point A. Can you tell me in which quadrant the point is lying? Think over. In which quadrant is the point lying? First, second, third or fourth? Just read its position with reference to VP and HP. The point A is, where is it? It is in front of VP and above HP. Is it not? This is top view. The top view is below XY. So I can say it is in front of VP. This is front view. It is above XY. So it is above HP. So in front of VP and above HP, which quadrant? It is first quadrant. If you have a point like this, which quadrant is this? Point B, it is behind VP and above HP. Is it not? The top view is above XY line. So it is behind VP. Front view is above XY line. It is above HP. Behind VP and above HP is second quadrant. Next. which quadrant? In which quadrant the point C lies? Pause the video and imagine. Based on this, point C is below HP and it is behind VP. Below HP and behind VP is third quadrant. And finally, D. D is in fourth quadrant. It is in front of VP and below HP. Point D is in front of VP and below HP. So in front of VP and below HP is for fourth quadrant. So this is how you can imagine when you are given the projections of a point. Now you are able to tell me in which quadrant the point lies. Yes. Now let me explain you why the second angle and fourth angle projection methods are not followed. There are two reasons for this. One reason let me explain from this sketch, and the second reason I'll explain from this sketch. Now, when we take first angle projection, or when a point is there in the first quadrant, what are the relative positions? The object is in between the observer and plane of projection. This is the position of the observer. He is there on the top right. So his position is on the top and also on the right. So when a point is there in the first quadrant, this is VP. So when you get the front view, observer, object and plane of projection, that is the order. Similarly, when you get the top view, this is the plane, horizontal plane you have to consider. Observer is there on the top, observer, object is there in first quadrant, and this is the plane of projection. So that order is defined clearly both for the top and front views. Observer, object and plane of projection is the order when you have an object in first quadrant. Similarly, when you have an object in the third quadrant, the observer position is fixed. He is there on the top and also on the right. So if you consider front view, this is the plane of projection. The observer is there, observer, plane of projection and object. That is the order for the front view. To obtain the top view, observer is there on the top, observer, plane of projection and object. Object is there in the third quadrant. So even here, the order is clearly defined both for the top view and front view. Okay. So there is no problem with the first and third angle projections or first quadrant and third quadrant. The only problem is with second and fourth quadrants when you consider the relative positions. Let me show to you. Let us say there is an object in the second quadrant. Now that is the position of the observer. To get the front view, we use the vertical plane. What is the order? Observer, plane of projection and object. The plane of projection is coming in between now. But when you consider the top view, this is the plane that you consider, horizontal plane. Observer is there on the top. Observer, object is coming in between, and this is the plane of projection. So the order is different for the front and top views. When you consider the front view, the order is observer, plane of projection is coming in between and object is here. When you consider the top view, the object is coming in between, observer, object and plane of projection. So the order is different for the top and front views in second angle projection. Similarly in fourth quadrant, for the top view, plane of projection comes in between. For the front view, the object comes in between. This problem you didn't have for the first and third quadrants. The order was same both for the front as well as the top views. This is one reason. What is the reason? The relative positions are not clearly defined for the second and fourth quadrants. This is one of the reasons why the second and fourth quadrants are not followed, or the second and fourth angle projections are not followed. The second reason, if you look at this sketch, we have discussed about the quadrants. When you take the first quadrant or third quadrant, if you look at the views, they are on the opposite sides of xy. When a point is there in the first quadrant, the top view is here, the front view is here. In the third quadrant, the top view is here, front view is here. They are on the opposite sides of xy. But if you take the second and fourth quadrants, this is the fourth quadrant, where are the views? Both the views lie on the same side of xy. Here in the second quadrant, both the views are on top of xy, and here both the views below xy. So when you make the drawings of, let us say, big machinery you want to draw, there is a possibility of the views getting overlapped because both the top and front views are on the same side. Here, in this case, even the points are getting overlapped here. Just points. Imagine a big machine. You are drawing the view of a machine. There is possibility that the views get overlapped, so you will not be able to visualize what actually is the drawing. That is another reason why the second and fourth projections are not followed. Okay, so this is a very important point. The reason why the second and fourth projection methods are not followed. Okay, it's a very important point. It is not explained in the books. Okay, but this is very important for anybody who is practicing engineering drawing to know this. Okay, so next class we will start with drawing number 2 in my next video, that is projection of points. This will be useful to you, the quadrants and all whatever is discussed, and also the distance of a point from VP and HP. So see you again in the next video.